Hey, welcome back to your favorite trigonometry class. We're going to take a look at phase shift, sinusoidal curve fitting as we graph sinusoidal functions of that form, as well as build some sinusoidal models from data using regression analysis. All right, so we're gonna take a look at functions of the form here and here. Okay, we've discussed previously amplitude, our period. Uh, Now phase shift, we're going to discuss. This is our right or left shift. Okay, a rigid shift here. So let's start out here. It's very similar to section 6.4 as well as we look at some key points. So the first thing we're going to do is we're going to take a look at, let me write the general form. This is A sine, this is the omega x minus phi, and plus b. Of course, this b is our vertical shift up or down. We don't have that in this case. So number one, our amplitude, which is half the distance from low to high, is the absolute value of 3. So it's just 3. Now that a is positive 3, so there's no reflection about the x-axis. Number two, let's take a look at our period. How long does it take to complete one cycle? So our period is 2 pi over omega. In this case, our omega, you can see, is the 2, right? There's our omega. So our period is pi. So, if we have that omega being bigger than 1, we're going to have that horizontal compression, right? So it's compressed. Instead of having a period of 2 pi, it takes only pi to complete one cycle. Now, number 3 is our phase shift. So our phase shift, that's a nice point we want to look at. In other words, it's saying instead of starting at like a 0, 0 for your sine function, it's shifting it right or left, and that's your first point you kind of want to start at. But the phase shift is defined as phi over omega, okay? Notice our phi here is pi, right? It's minus phi, so minus, and notice this case pi. So it's positive pi. Our omega here is 2, okay? So if our omega is positive, it's going to shift this thing to the right, pi halves. Okay, so you might want to think about, your transformations here. Let me write this a different way. Y equals, by factoring out the 2. If I factor a 2 out, right, when I distribute it back, so I'd have pi halves right there. This is the exact same thing as 2x minus pi, right? So what we've done is we've vertically stretched by a factor of 3. We've horizontally compressed this thing, and then we've shifted it right, so horizontal shift right, pi halves, right, if you're thinking about your transformations. So when we do our key points, instead of starting with an x value of 0, I'm going to start here, my phase shift. That's my first x value, so pi halves. So that's my first one. Let me put my key points up here. Key points. So pi halves. That's my first one. Now, what we're going to do, if you remember from section 6.4, is we're going to take a fourth of our, let me erase some of this stuff here. So the next key point would be, I'm going to split my period into fourths. Period into fourths. So I take a fourth of what's my period? My period is pi. So a fourth of pi. Pi force, if I go up pi force, so I take the pi halves, my phase shift, that's my first point, and then I go up pi force from there. So pi halves plus pi force. So that's 3 pi force. And then from that point, 3 pi force, again I go up another pi force to pi. 3 pi force plus pi force, 4 pi force. And then I take the pi and I go up another pi force. So now I got 5 pi fourths, and I go one last time. So I do this 4 times. 5 pi fourths plus pi fourths, 6 pi fourths, or 3 pi halves. And that'll give me 5 key points where I start and I end one period later. You know, because if you go a full cycle, it's one period, or pi. So pi halves plus pi, well, that's 3 pi halves. So I want to end my last point a period away. And then we're going to plot those points, right? So we're going to put those in one by one. So I got y equals 3 sine 2x minus pi. I'm going to throw in pi halves first. 3 sine 2 times pi halves minus pi. So I got pi minus pi. Sine of 0 is 0. So I got 0. Now we're going to plug in 3 pi fourths. 2 times 3 pi fourths. So now I got 3 pi halves minus pi. So 3 pi halves minus 2 pi halves is pi halves. The sine of pi halves is 1. So this ends up being 3. And I keep going. Now let's plug in 2. I got sine of 2 times pi. 2 pi minus pi is pi. Sine of pi is 0. 0 times 3, 0. So 0, 3, 0. Take 5 pi fourths. 5 pi fourths times 2, 10 pi fourths, which is 5 pi halves. Minus pi is 3 pi halves. Sine of 3 pi halves is negative 1 times that 3 in front. We got negative 3. And finally throw in the 3 pi halves. And you're going to have, you can draw this thing. If I clean this up a little bit. Leave that stuff there. So I've shifted this to the right pi halves. So that's my starting point. And I'm going up by pi fourths amount each time. So I'm going up 3 pi fourths, pi, 5 pi fourths, that's a 5 pi fourths, and then 6 pi fourths or 3 pi halves. At pi halves it's 0. At 3 pi fourths I got 3. At pi I've got 0. At 5 pi fourths I've got negative 3. At 3 pi halves I've got 0. And I can see my graph. Let's take a look in decimals now of 3 sine 2x minus pi. Y equals 3 sine 2x minus pi for pi. And what I'm going to do, I'm going to change this. Here's how you change your window, of course. Let me go from, I don't know, negative 2 pi to 2 pi. Let me have each step be pi fourths. You know what, actually, let me go from negative pi halves, and let me go clear to 4 pi. Be a little bit better. And then we'll just go from like negative 5 up to 5. Step 1 there. Make sure you're in radians. And you know what? Let me label each. Yeah, I went by a step of pi fourths. That's fine. So notice pi halves 0, first point. 3 pi fourths 3. Pi 0. 5 pi fourths negative 3. 3 pi halves 0. Right? We've shown the one cycle there, and of course it just repeats that cycle. Okay. Get back here. Oops. Alright, now we got a cosine here. Y equals a cosine omega x minus phi plus b. Now notice we've got a vertical shift down 1. But let's go ahead and go through all our steps. Number 1, our amplitude. Absolute value of 4, 4. Now that's not a negative 4, so there's no reflection about the x-axis. Our period, 2 pi over omega, which is 2 pi over, notice our omega is 2. So we've got another period here of pi. Okay, so when we do our key points, we want to cut that in fourths, or at a fourth of that, so going up by pi fourths each time. 3, let's do our phase shift. Now notice we've got a plus right here. So another way to think about this, this is the same as 2x minus a negative 3 pi minus 1. In other words, our phi, which follows the negative, is negative 3 pi, right? Because the signs disagree there. So our phase shift, which is phi over omega, is negative 3 pi over 2. Okay? Let me rewrite the original function so you can see the transformations. Originally it's written 4 cosine 2x plus 3 pi minus 1. If I rewrite that so you can see the transformations by taking a 2 out, right, this is the same thing. Now we see vertical stretch by a factor of 4, horizontal compression. So instead of a period of 2 pi, we got a period of just pi in this case. And then now we've got the horizontal shift left, 3 pi halves. And then we've got a vertical shift down 1. Okay? So let's do our key points. So 4 is our key points. We're going to start with our phase shift, negative 3 pi halves, right? We've moved it off of, instead of starting at an x value 0, since we moved it left, 3 pi halves, let's just start there at negative 3 pi halves. Now, we're going to go a fourth of this period, which our period is pi, right? So a fourth of pi. So we're going to go up by pi fourths each time. So this next spot will be negative 3 pi halves plus pi fourths. So that's negative 6 pi fourths plus pi fourths, negative 5 pi fourths. And then negative 5 pi fourths plus pi fourths is negative 4 pi fourths, so negative pi. Negative pi plus pi fourths, negative 3 pi fourths, and then negative 3 pi fourths plus our last pi fourths ends up being negative 2 pi fourths, or negative pi halves. And then we throw them in. So we have 4 cosine 2x plus 3 pi minus 1, 4 cosine 2 times negative 3 pi halves. So negative 3 pi plus 3 pi, I got 0. So I got 4 cosine of 0. I know the cosine of 0 is 1. So this ends up being 3. Right, and then we just keep running through that. So I got 2 times negative 5 pi fourths, negative 10 pi fourths, or negative 5 pi halves, plus 3 pi plus 6 pi halves. So we got pi halves. Cosine pi halves is 0. 0 times 4 is 0. 0 minus 1 is negative 1. Anyways, we kind of keep going through that. You can plug them in. That one will end up being negative 5. That one will end up being negative 1. And then you'll end up with 3 right there. And then we can plot those. Now this time I'm going to so I'm going to start at negative 3 pi halves. Remember, this is going up by pi half. Let me go. So negative 3 pi halves, we got 3. There's the start of our cosine. Negative 5 pi fourths is negative 1. Right, this is like the center. Remember, it's been dropped down 1, so instead of this, the middle of the graph, if you will, being at y equals 0, we got the middle of this thing being at down 1, like negative 1. Okay, that axis of revolution, if you will, right? Negative pi, we got negative 5. Down here. Negative 3 pi fourths, I got negative 1 right here. And then negative pi halves, I'm back up to 3. So we're going down. And so on. And it just repeats that again. Right? Put this in decimals. 4 cosine 2x plus 3 pi minus 1. Y equals 4 cosine, what was that, 2x plus 3 pi minus 1. Just move this over a little bit, and you can see there's our negative 3 pi halves, 3. And then our next one was negative 5 pi fourths, negative 1. Let me put the points in for you here. And there we go. There's our points we just plotted beautifully with the Desmos. Okay. All right. So now, what about if we're fitting a sine function to data in the Now, what I'm most concerned with on this is that we can be able to punch it in and find a regression model, a sinusoidal regression model. But let's walk through if you were to estimate this by hand. You can see, and I'll punch this into decimals. I'll show you how to do this in decimals, okay? So here's our data. We got our January months, right? Here's our inputs, our months. We got our outputs, which is our monthly temperature here. And what we're going to do first to find the amplitude, if you were to estimate this, so if we just estimate it by hand, take your largest data value, the 74.2, minus the smallest data value, which is 30, divided by 2. There's your amplitude. And you notice here, it's going up initially, right, like the sine function. So we got a positive on this thing, 22.1, okay? Sine x. So we're at this point, we have our amplitude. Number 2, you can see what we have so far, 22 sine x. Now you notice we got to shift this thing vertically, horizontally, and we got to stretch this thing. Okay, so the vertical shift. Let's move this thing up. So go ahead and you take your largest plus your smallest divided by 2. You take the average of those two. So 52.1. That's what we're going to throw on to the end of our 22.1 sine x. So we shift it up. Now you see what we have, right? It's shifted up. It's getting closer to our actual data. You see the little points is our actual data. So now we got to shift this thing horizontally as well as stretch this thing out horizontally, okay? Now the data, because this is weather related, it's cyclical, right? Your average temperature is going to repeat each year, so every 12 months. So your period is 2 pi over omega, which is 12. So if you just solve for omega, right, multiply both sides by omega, omega, and then divide both sides by 12, you got your omega being pi 6 on that. So now we got our omega piece. And we're getting closer, right? And you notice we've got, oh, here it is. We're getting close, but what do we need to do? We still need to shift that thing horizontally, okay? And right now, what's going on is if you were to look at this in your decimals, you have this point is occurring right now. If you're going, in fact, I got this written out right here. Sine curve is increasing from 0 to 3, and then it's decreasing. So right now we've got this max at x being 3 right here, okay? But we need this to occur at 7 months, at an x value of 7, right? Not at an x value of 3. So we got to shift this to the right 4 units. Okay, so we've got to shift it to the right, 4 units to the right, so we've got to replace x with x minus 4 in our function. So we had y equals 22.1 sine of pi 6x plus 52.1. Shift it right 4 units. That goes in. So 22.1 sine pi 6x minus 4 plus 52.1. Or if you distribute that, end up with that. Okay, so that's how you want to think about that. That's just getting an approximate kind of a, it's a pretty good kind of by hand estimate of our A, our omega, our phi, and our vertical shift up or down on that. Okay, here's how you would do that in Desmos. Get a much better model. It's called a sinusoidal regression model. Let me clear all this out. Let me start over here now. What you do is you hit this plus right here, and you're going to create table. Okay, so again, I hit plus table. Now notice I have x1, y1. So it's asking me, hey, punch in the data. Let's see if I get the data here. The months, and then average monthly temperature. That one was 30.7. Next one was 32.5, 40.4. 47.4, 7.1, 7.4, 74.2. Alright, so I got all my data. Okay. Now if I did kind of, let me go from like, I don't know, -1 to 20, 15, whatever. And notice my lowest is 30s. I'll just do -5 up to my highest is up to 80 or so. Highest there is 74.2. You can kind of see it, right? You can see these January 30.7 average monthly temperature, February 32.5 average monthly temperature, and so on. And kind of see this looks like a kind of a sine curve, right? So what we're going to do now is we say I got my data based on x1, y1. So let this run the algorithm based on y1. So I hit y1 tilde a sine bx1, because I got to have x1 data, minus c plus d. And what it does is it finds, using regression analysis, okay, so it's an algorithm in Desmos or whatever calculator you're going to have. You may have slight variances between your softwares that do this, by the way. But they're all going to be pretty close for your parameters. But it gives you, hey, A is 21.5334. We were pretty close. We had like, what was it, 22.1 or something. So 21.5334. Our B, our omega, is 0.561916. Our C looks to be 2.43985. And our D is 51.7812. We approximated our D, our vertical shift, to be about 52.1, right? So again, pretty decent, but this is much better, and that's how you're going to approach that with your sinusoidal regression. Here it is with a TI 84, I believe, on this. Okay, if you run that sinusoidal regression with that. Okay, Thank you so much for listening, and we'll see you guys next time. That's our phase shift discussion for today.